Let us look at some properties of numbers and try to see if we can understand implication properly. You see, what's a prime number? A prime number is something that does not have any divisors. 7 is a prime number, 11 is a prime number. You cannot find a number which divides 7. You cannot find a number that divides 11. 19 is a prime number, right? 53 is a prime number. You cannot find a number that divides 53. So now, whenever you take a number that is not prime, let's say A is not prime. Take any non-prime number. It implies that A square is also not prime, correct? Goes without saying. When you take some number and take its square, that square will always be divisible by A. A square is always divisible by A, and hence by the definition of prime number, A square is not a prime number. A is not prime implies A square is not prime. Let me take another example, second example. A is an even number implies A square is an even number, correct? Why? Whenever A is even, A is of the form 2n, A square will be of the form 4n square, which obviously is an even number. As you can see, you have a multiple of 4, which is always even. So A is even implies A square is also even. Now let us ask a question. If you are given that A square is even, does it imply that A is even? A square is even indeed implies A is even. Why? If A were to be odd, square of an odd number should be odd. If A square is even, then definitely that particular A whose square is giving you A square and hence becoming and you observe that it is even means that A is even. Think about it for a minute. Take a pen and paper and then work it out. A square is even implies A is even. But then we saw A is even implies A square is even. If P implies Q and Q implies P, we say P two-way implication symbol is how we write this as two-way arrow. P implies and is implied by Q is how we say. By that we mean P and Q are equivalent. Because when P is implying Q and Q is implying P, they both are one and the same. Remember our subset example that we said. P is a condition which implies that Q is also true. Q is a condition which implies P is true. So whenever a set A is within B and this set B is also known to be within A subset of B and B subset of A implies A is equal to B. This is only obvious. Correct? So P implies and implied by Q is written with this bidirectional arrow, and it simply denotes the fact that P implies Q is true and Q implies P is true. And the truth table of this P implies and implied by Q looks like this. If P is 0, Q should be 0. Both are of the same parity. That's what the bidirectional thingy means. So it is true. If P is 0 and Q is 1, that is impossible. It is false. If P is 1, Q is 0, false. If P is 1 and Q is 1, it is true. So this is the truth table of P implies and implied by Q. You will observe that if you were to write the truth table of P implies Q and Q implies P and do an AND of it, it will resemble this 1 0 0 and 1.